Welcome to the lesson on literal equations. We will be solving literal equations where we will be solving equations for variables. So let's go ahead and begin. So a literal equation contains two or more variables. In fact, every formula that you come across in math or science is a literal equation. And of course, you'll solve for a given variable by isolating that variable in the same way you would when solving a regular linear equation. So let's go ahead with some examples here. So for the first example, we have the formula for the area of a rectangle, which is A equals L times W, or area equals length times the width. So we're told to solve for W. So let's go ahead and do that. Let's rewrite the equation here. So A equals L times W. So since we're multiplying, we need to divide. So remember, we're solving for W, so we need to divide by L on both sides. So notice the L's cancel. And so we're left with W is equal to A over L. Okay, so let's go ahead and go over example 2. So for example 2, we have the formula for the circumference of a circle, which is C equals 2 pi r, and we're told to solve for pi. So let's go ahead and do that. So C equals 2 pi r. Okay, so we're multiplying here. So let's go ahead, let me change the color. So what we're going to do, since we need to isolate pi, is we can actually multiply by 2r on both sides of the equation, right? Because we're still multiplying by 2r up here, even though we have pi here. Okay, so notice the common factors of r and 2 cancel. So that leaves us with pi. So pi is equal to C over 2r. So let's go over example 3. So for this example, we have the formula for converting degrees Fahrenheit to degrees Celsius. So, and that's C equals 5/9 times the quantity F minus 32. Okay, and so we're told to solve for F, or Fahrenheit. So let's go ahead and do that. The first thing we can do is go ahead and multiply by the reciprocal of 5/9 on both sides of the equation. So the reciprocal is 9/5. Okay, so notice the reciprocals cancel, because when you multiply reciprocals together, you get a result of 1, or a product of 1. So now we can rearrange this to where we can remove the parentheses from the quantity F minus 32. So let's go ahead and do that. So we have, let's bring everything else down first. We have 9/5 times C is equal to F minus 32. Okay, so now we have minus 32 here, so let's get rid of that by performing the opposite operation, which is adding 32 to both sides of the equation. Okay, so now the minus 32 plus 32 cancels. So let's rewrite this to where the variable is on the left side. So we have F is equal to 9/5 C plus 32. Okay, and here we have solved for F. Okay, so let's go over the last example, example 4. Okay, so for this example, we have the formula for the perimeter of a rectangle is P equals 2 times the length plus 2 times the width. Okay, and we're told to solve for L, which is the length. So let's go ahead and do that. Rewriting the equation, P is equal to 2L plus 2W. Okay, so right away I can see that the first step in trying to isolate the L is by subtracting 2w from both sides of the equation. Okay, so the plus 2w minus 2w cancels. So let's rewrite this to where 2l is on the left side of the equal sign. So we have 2l is equal to p minus 2w. So we still need to isolate the l, so we need to get rid of the 2 by dividing by 2 on both sides. So let's go ahead and do that. So notice the 2's cancel, and so we are left with L equals P minus 2W over 2. So this is one way that you can write this solution. However, there's another way that you may see this written, and that's where you're going to take each individual term in the numerator and divide it by 2. So this is what I mean. So you have L is equal to P over 2 minus 2W over 2. So notice the 2's cancel, right? Because they're common factors. So we can cancel those out, and we are left with L is equal to P over 2 minus W. So just notice that you will see this written both ways, but I wanted you to see that just in case you see that on an exam. Okay, so that's all we have for this lesson. Hopefully it was helpful to you, and I look forward to working with you in the next lesson. Take care.